Morning, students. So in the previous class we had done partial fractions. Now in this class we are going to do integration by parts. This is 7.6 exercise as per NCERT. So let us start this. So basically integration by parts. Here you will have product of two functions. U is first function and V is another function. Now we want to integrate. So as per formula, this is first function as it is, integration of second minus derivative of first function, integration of second function, then whole integration. So this is formula for integration by parts. So whenever we have product of two functions, then this is how we will proceed. So I had written this example, this is x into ex dx. Now let me assume that this is my first function and this one is my second function. So here I am applying integration by parts. First function as it is, integration of ex dx minus derivative of x, integration of ex dx, then whole integration. So this will become x ex minus derivative of x with respect to x is 1. This is ex. After that 1 into ex is simply ex and integration of ex is ex plus c. You will write this plus c when you integrate this last expression. Now after this is very important that to decide first and second function. So we have to decide which one is first function and which one is second function. So for that we have this rule which says ILATE. Now here I stands for inverse trigonometric functions. For example, tan inverse x, sine inverse x, etc. L stands for logarithmic functions. Logarithmic functions, log x, log 2x, etc. Then we have algebraic functions, x to power n, x to power 0, x to power minus 2, etc. Then we have trigonometric functions, sin x, cos x, cot x, etc. That lastly we have exponential function, e to power 2x, e to power minus 2x, etc. Now the order for deciding first function will be this downward. So this is how you will decide your first function. You will follow this order. So for example, in this one, we have a combination of algebraic and exponential. So you can see this order. Here, algebraic comes over here. So algebraic comes first. So that is why we are taking this as a first function and exponential as a second function. And then we can apply integration by parts. So this is important to decide first and second function. Now, let me give you some more example where you have to apply this integration by parts. So example number 2 you can consider as x into sine 3x dx. Okay, so here I have a combination of algebraic and trigonometric. So first of all, as per that rule, you can see that a comes first, t comes later. So this will be treated as first and this will be treated as second. Now let us apply integration by parts. So as per that formula, first function as it is, integration of sine 3x. So let us do it. So integration of sine 3x was minus cos 3x upon 3 because of extension formula which we had done in 7.3 exercise. As per that, I can write this as cos 3x upon 3 with a negative sign. Then derivative of x with respect to x is 1. So this will be cos 3x upon 3 dx become plus. So finally I can rewrite this as cos 3x dx. Finally you will get this as cos 3x upon 3 plus 1 upon 9 sin 3x plus c. So in order to integrate sin 3x, we had written cos 3x upon because of that extension form. So again I am here integrating cos 3x. It is sin 3x divided by 3. Right? So this is another example. Now let me write down some more example where we need to apply this integration by parts. So you can write down example number 3. Suppose we have x square into ex dx now. Now here again you can see that we have a combination of algebraic and exponential. So as per that ILATE, we have to take this as a first function and exponential as a second function. So let us apply integration by parts. So you will write first function as it is. Integration of ex is simply ex. Derivative of x square will be 2x. Then integration of ex will be ex dx. Now you can take this 2 outside the integral. Now here again we are getting product of two functions. So again we are supposed to apply this integration by parts. This will be treated as first function. This will be treated as second function. So let us apply. So first as it is integration of second minus first ka derivative integration of second dx. So finally you can rewrite this as e bar x square into e bar x ex minus ex plus c. This will give you a final answer. Now, third example, you can write down this. Let me write down one more example. So number 4, suppose you want to integrate x to the power 3 plus 1 into log x dx. So here we have a combination of algebraic and logarithmic function. So I will treat this as a first function and this one as a second function. So let us apply integration by parts. So first function as it is, integration of second function x to the power 4 upon 4 x minus derivative of log x is 1 by x. Integration of second function will be this. Now here we need to do some calculation work. This I had written as it is. Now here I can take x common, I can cut it out. So I will get this as x to the power 3 upon 4 plus 1 dx. Now finally we will integrate this expression. So when finally you integrate this, it will become x to the power 4 upon 4 minus x plus this will become x to the power 4 upon 16 minus x plus c. So this will be your final answer for this particular question. Okay, next number 5. Suppose I want to integrate x into sec square x dx. Now here again, I can see that we have a combination of algebraic and trigonometric. So algebraic comes first, a comes first, so this is first function and t will be treated as a second function, trigonometric. Now let us apply integration by parts. So when you apply that, you can write this first as it is integration of sec square x was tan x minus derivative of x is simply 1. Integration of sec square x is tan x. So finally we can write this as this much. So x into tan x. Finally we want to integrate this tan x. So again it's a formula of log sec x plus c. When you apply it, this can be written as log sec x plus c. This is how we can integrate this particular question. Number 5. Let me give you one more example. Suppose if we want to integrate x into sine inverse x. X into sine inverse x. Now here we can apply integration by parts directly or we can do it by substitution method also. So let us do it by substitution method here. So when you apply substitution, we will take x as sine theta. So dx will become cos theta d theta. So this I can be written as sine theta, sine inverse, sine theta, cos theta d theta. So in place of this dx, I had written cos theta d theta. This x will become sine theta, and this is sine inverse sine theta. Now I can rewrite this as theta into sine theta cos theta. So what I am getting now, in order to write this as sine 2 theta, I will multiply and divide it by 2. When I multiply and divide it by 2, this is how I can write it. Now, on this expression, we will apply integration by parts. So this is algebraic and this is trigonometric. So this is first function, this is second function. Let us apply that. So first, as it is, integration of sine 2 theta is cos 2 theta divided by 2 with a negative sign. Derivative of theta with respect to theta is 1. This will become cos 2 theta upon 2 theta. So we can write now. We need to integrate this expression. So finally, we will get this as, finally we can write this as minus 1 upon 4 theta cos 2 theta minus 1 upon 4 integration of cos 2 theta d theta. This cos 2 theta can be written as sine 2 theta upon 2 plus. Now we have got the answer, but it is in terms of theta. We have to convert this in terms of x. So how to do that? This can be written as by this substitution. If we see it carefully, then x can be written as sine inverse, x can be written as theta. So let us substitute the value of theta over here. So I can write this as sine inverse x is the value of theta. Now cos 2 theta can be written as 1 minus 2 sine square theta. And this can be written as sine 2 theta can be written as 2 sine theta cos theta upon 2 plus c. 2 and 2 will cancel out. So if I want to write this in terms of x, and finally I can write this as 1 minus 2x square, because you know that sine theta stands for x. So sine square theta will be 2x square. And here I can write 1 upon 4 sine theta can be written as x, and cos theta by class 10th identity can be written as 1 minus sine square theta, which can be written as 1 minus x square plus c. This is how you will leave your final answer. So this cos 2 theta can be written as 1 minus 2 sine square theta. Because our substitution is x is equal to sine theta, so intentionally we are applying this formula for cos 2 theta as 1 minus 2 sine square theta. So 1 minus 2x square, then sine theta is x. Cos theta can be written as under the root of 1 minus sine square theta, which can be written as under the root of 1 minus x square plus. On the basis of this, from this 7.6 exercise, you can do first 15 questions. Thank you, students.